Hi, I'm Scott Hunter, and welcome to .NET Conf Day 2.
All right.
2024, .NET 9. Super excited about this. So I'm here with my friend Paul Yuknovich.
Hey, everybody.
And we are going to talk about building cloud-native applications, and we're going to throw some intelligence in there as well.
Yep.
Should be a fun way to get started. We're going to talk a little bit about the history of .NET as well. So with that, let's just kind of jump in. So Azure is the best place to host .NET applications, and we're going to show that. We're going to show some functions today. We built a product called Web API and .NET around 2012 when we saw that APIs were going to be at the forefront of the future of the internet. And so we built that feature, and we're going to show how you can take a traditional ASP.NET Web API, and it's so easy to move to an Azure function, which is a highly scalable PaaS platform serverless, which means you're only paying for the compute while you're actually, your calls are being made. You're not buying that virtual machine the entire time.
Totally, and it can burst like crazy. It can go to 0.
Exactly. So we've got this new feature that we're gonna ship in about a week. It's in preview right now. It's called Flex Consumption, and that's a new SKU of Azure functions that, as Paul said, can burst from like 0 to 100 in just a few seconds. And then jump back down when the traffic goes back away. And then we're going to show how also Azure Functions enables an easy path to adding AI to your applications. You know, you've probably seen all the articles and read all the stuff and said, wow, there's a lot of tech. Paul's hopefully going to show us how in just a few lines of code, you can do some of the cool stuff you've seen. And then finally, he's going to show some advanced AI features as well.
Yeah, it's like the easy things are really easy. The hard things are actually getting easier. So I can show you all that.
You know, as we're talking about scale, what makes .NET amazing is, you know, we don't just build it in a vacuum. Because we're part of Microsoft, we get to actually build it, and many of the services that you rely on for the stuff you run today is powered by .NET. You can see here we've got Microsoft Graph, Microsoft Entra ID, Microsoft Teams, Cosmos DB, Exchange, Azure App Service, and many, many more are built on .NET. And one of the things that makes .NET great for hosting cloud applications is look at the scale of some of this stuff. Graph with 70 billion requests a day, Entra ID, 185 billion requests a day, Microsoft Teams, tons of projects. But the big thing is look at these CPU numbers and how they change as we do these each version with more optimizations for performance. You can see how we're saving, you know, each of these teams money by using .NET as their primary technology. I can slide down here to Cosmos, and once again, you can see 30 to 65% CPU savings, Exchange, 26% CPU savings, in App Service, 80% throughput. We just enabled gRPC earlier in the year, I think, and HTTP2. And this is one of the benefits of building .NET in Microsoft is we actually get to test it and run it at crazy scale ourselves. And so when you run your apps on .NET, they should be awesome because we're running it at this kind of scale.
One thing I don't know if everyone knows, Functions is actually a big .NET app. And we just upgraded to the latest version. We saw all kinds of perf improvements. And we're excited to take 9 now and take those improvements too. So we're even experiencing those benefits.
We were just talking to the bosses yesterday about those performance improvements. Seriously, Paul and I literally were in a meeting with our boss yesterday talking about those kinds of changes. You know, one of my favorite features in .NET 9 that we're not going to focus on because we're just going to focus on building APIs is when people compare .NET to other things like Go or Rust. Traditionally, you would see .NET use more memory, and that's because our memory allocator, our garbage collector, was aggressive and would grab a lot of memory when it first started up. We've turned that down in .NET 9, and so now it has we have a similar footprint of memory on a device, which is kind of cool.
That's cool.
Got to nerd out here. And then here's just an example of, you know, I just talked about a bunch of Microsoft stuff that runs on .NET, and here's an example of like 4 companies that are also heavily invested in .NET. So anyways, .NET's great for the cloud. You can see that here. And with that, let's move off to some demos and stuff, Paul.
Let's do it.
So
you're going to go first today, right?
I'm going to go first today.
That's the way to do it.
I was goofing around and once we get close to .NET Conf, I was reading this blog post that the .NET team put up on the RC release, and it's the first version of Aspire that has Azure Function support. And as we mentioned before, if you build a web API today, you probably host that somewhere where you've got a virtual machine or some service in Azure that's running full time, 24 hours a day, running your web API. And Paul and I think that you would be very interested in doing serverless functions, because in that case, you're not running the VM 24 hours a day. You're running it for however long your function runs, which can be a lot less time. And if I'm going to scale up, do I really want to run 10 VMs 24 hours a day or 100 VMs 24 hours a day? Probably not. And so I was excited to see that we've added Azure Function support in .NET Aspire. And for fun, what I did is I took this. This is a blog post that shows this, and I have not done any of this stuff, Paul, since like high school. But their sample was this translate to Pig Latin.
I can't get my head around that anyway. I need the machine.
I need the machine too. I don't know. We did this in high school, and I don't know how we did it, but
my sister was good at it.
But it's just an example of something. And so what I did is I went and said, let's go put this in a traditional ASP.NET Web API. And I mentioned earlier, we created ASP.NET Web API around 2012. It ran on .NET Framework at the time, and the goal of that was to make APIs were going to be super important, and we wanted to make them easy to use in .NET. And so I assume you probably used Azure Functions before. I mean, used ASP.NET Web API before. But the big thing here, if you look here, here's my primary function. And the most important thing here is when you're doing a web API, you're doing REST. That means you got payloads coming in a certain format. You're going to return the payload in a certain format, and those formats are not natural to a developer.
No.
I don't. Back in the early days, what we would do is you would parse the input and break it out into a bunch of parameters, and then you were going to make a result. You would then take all the data you have in .NET types and convert that back to JSON.
And you realize you got the casing wrong.
Yes.
And you debug it for another half hour.
And so the point of Web API was to basically do that work for you using something called model binding. In this case, I just have an input text, which is a record which contains a value. And on my result, once again, just a result. I don't have to actually do any of the JSON parsing here. I just do the code like I'm used to doing the code, and it just works.
One thing I'll mention too, before functions you'd look at and you say, hey, that's not really the .NET type system. It's kind of its own.
We're going to show that.
Oh, okay.
So we're going to show that. So,
okay.
So, and this is the same stuff I stole from that blog post. But the big point here is this is what something looked like around 2012. We got rid of all the JSON parsing. You got the model binding. Just use the types like you want to use, and you're kind of good to go. But I want to show some of the challenges of this technology. So if you've been doing .NET for a long time, you're probably used to this. What does this actually run on? When I run this, I opened up the properties file folder, and inside of there's a launch settings.json, and it's going to contain the port, the web address, and the port that we're running on. So you can see 34237 for HP. And how am I ever going to remember these things? These are, once again, if this is what Aspire kind of solves.
You need a tool really to create that kind of stuff, right?
You need a tool. And so I actually put a Blazor front end on this thing, and I want to highlight that my Blazor front end is a little fragile, because if I go look at my homepage here, you're going to find it's got that same URL baked into it right here. Yuck. That means if I want to publish this to Azure, it's not going to work really well, because I'm going to have to publish the front end, the back end. They're not a continual unit piece like I want them to be. And so, this shows some of the fragility of this. And so for fun, another challenge here is I've got multiple projects. And so Visual Studio's never been great at running multiple projects. Our command line's never been great at running multiple projects.
Yep.
I've done the trick where I can go over here and right click, and I've done startup, I've set up my startup projects here.
Oh, like solution order kind of stuff?
So you do all this solution ordery stuff. I have to decide here if I want to start with debugging or not debugging.
Yep.
Not a great story. And this is something we solve with Aspire, but I just want to show that the app runs. So let's do this. Start without debugging. It's going to boot up one project for my back end, one for my front end. It's going to go and bring up the weather for fun, because I started with a default web API project. And I can do welcome .NET Conf 2024. I'll click that. It went and called the API, returned all this. So it works, but it's not something I could easily copy and publish to Azure without doing a bunch of work. I'd have to go find a way to take those URLs and convert them into configuration, which is dangerous. I could do environment
Even as Hello
variables.
World, it's a lot of DevOps stuff.
A lot of stuff.
Yep.
So next step was I want to take this web API and I want to convert it from a web API to an Azure function. So I'm going to start with that. So let's go and open another Visual Studio. And one of the things that Paul and I both work for the team in developer division that builds a bunch of our Azure PaaS services.
Yep.
And one of the goals we had with Azure Functions over the last couple of years was make it feel native to every language. When it was first created, it was kind of its own programming model. And so whether you're Node.js, your Python, your .NET, we've done this effort to make it feel natural to all of those different technologies. So I'm going to go and open up the function. And there's a couple things that are different here. And let me go move back over here, and I'll open the same.
So I got excited when I saw the word function before, and I just started going.
So once again,
Yep.
same input, same types as you said before. Same action result, same from body, same. I'm on the wrong one. Same action result, but there's a few things that are different here. Number one is there's a trigger, HTTP trigger attribute here with authorization levels. And that's because this is going to run in the cloud.
Yep.
And because I'm running in the cloud, I've got to be explicit and say,
Yeah, you should be really intentional if you do something anonymous in the cloud. That's our position. So we give you some options to do something different.
you're going to notice the same from body with the input text stuff that we had right over here. Looks exactly the same.
Yep.
There is this one new type that kind of comes in that just kind of gives me access to all the stuff.
Yep, the whole kind of function lifecycle.
If I wanted to go manually parse all the stuff and go look at the actual input being sent to me, I could go right there. But I want to highlight the same logger, the same results. This code looks exactly the same almost.
It's
Paul.
the same. I think over the last year, we've really hit that parity. And you also own main, which I think is a cool thing.
Yes, which is how I can do things like the logger, all the things you would expect in an ASP.NET Core project.
Yep.
Translate to this. This works exactly the same. And by the way, it's going to have the same challenges as well. I've got my launch settings. Inside of there, there's a port 7226. And my Blazor application, once again, is going to have that same challenge of having to be hard-coded to that 7226. And so even though this is more ready for the cloud because it's built on our serverless function. So if I publish this, unlike the first app, if I publish the first app, my virtual machine is going to run the entire time, 24 hours a day.
Yep.
Took almost exactly the same code, added one parameter, added an attribute, and now it runs on serverless functions, which means I'm only going to pay for what I use, and I've got this burst capability to scale.
And even a much smaller size, right? Just the memory you're using, just the CPU.
And so let's take it to the final level. And after we get off the stage today, Sophia and Matthew are going to come in and actually do a deeper dive on using Aspire with functions. But I got all started, I said again with that blog post saying, hey, I can run this inside of Azure. So super cool. So I'm going to switch to the final version of this. And Paul's got slides later that will actually give you, if you want to try any of these things, you can grab this stuff and try this stuff. So this is an Aspire version of this. So what I did is when I created my function this time, there was an option to check for Aspire orchestration, which is something if you've tried Aspire before, you'd be used to. Now, a couple things are different. Now I've got my Blazor front end like I've always had. I've got my Aspire function like I've always had, but I've got this new app host. And this is the code that kicks it all off. Before I did that weird startup project thing. Now my startup project is really this app host. And if I drill in the app host and go in here, you're going to basically see I've got this new builder.add Azure Functions project. I poked that at my Functions project. I've got my Blazor front end. And if you've not seen Aspire ever before, when you create a project, you give them a name. And I never use those hard-coded ports and IP addresses again. I just use these names.
Thank goodness.
Exactly. I hate this stuff. And then my Blazor project wants to have a reference to functions because it's going to call the function. And this is a new feature in Aspire 9 is wait for. And what wait for does is wait for says, I'm going to wait for make sure that other project starts.
Nice.
In Aspire 8, the wait for, the with reference sort of waited for that process to start.
Yep.
But the process starting doesn't mean it's ready to handle a request. And so the new wait for says, not only do I want to wait for that project to start, I want it to actually be ready to take a request.
It's almost like a health check built in or something?
It's a built-in health check.
Oh, that's cool. Yep.
And then finally, you saw the attribute before on the function saying what the type is. I need to tell Aspire whether any of these things can be accessible on the public internet. And so that's what this with external HTTP endpoints does. Now notice I did not put that on the actual function. That means the only thing that can ever call that function is going to be the web front end.
That's awesome. So it's network isolated by default.
It's already network isolated by default. One of the features of container apps, which is the default way of publishing in an Aspire application. And I'll show the final piece of this, which I'm going to go back in to my Blazor application. I will go into, let's go in here. No, I am losing myself. Let's go here. And you're going to notice that I no longer have any ports or IP addresses. I just say HTTP function, and I say that because, once again, if I go back to the app host, I called it a function.
Nice. It's like a DNS name almost.
It's DNS names.
Yeah.
And
sweet.
so now I get all the cool Aspire capabilities with an Azure function. So we'll run this. And let's give it a second there. And now when I run the application, I get this really cool dashboard that shows me a couple things. Interesting here, Paul. What is this? Oops. Azurite. What is Azurite?
Sounds like a cool thing I'd see in Minecraft, almost. Oh, that's netherite. It's, okay, in all seriousness, that's the storage emulator.
So an Azure function requires storage for a couple of its capabilities. We're trying to remove that requirement but it's still there today.
Yep.
And so what's cool here is, normally if I'm using Visual Studio and I click the Azure box when I'm installing Visual Studio, it's going to install Azurite for me. But with an Aspire application, I no longer have to worry about that because now Aspire is going to go boot it up in a container, less stuff to install on my machine. But that's one of the pieces that makes this work.
You have to think about authentication, all these things. That makes it just so much better.
And now here's my function, here's my front end.
Yep.
I get all the things I would want. I can go and say, show me my function, and here's all the logging that's running on the function. I can go back to my Blazor front end and see that. So it's exactly what you would expect. I can now do, let's go click on the front end. There it is. And it should take a second. There you go. Get the result back. Obviously, I can't read that.
Me neither.
Et ne. Oh, yeah. Okay. It's kind of cool. And once again, if I go back to the dashboard, I would expect all the things. I can go and say, go show me the console. Go show me the console for the function. I put some logging in there.
So the whole observability is just working now.
You're seeing all there's my logger writing the request, and so I get a great dashboard to find all this kind of stuff. We don't have time to show it, but I did publish the app to Azure as well. And one of the goals of Aspire is to do all the right stuff. I see a managed identity here, Paul.
Oh, thank you, sir.
So we're doing all the right stuff. So nothing's using credentials and configuration files or anything like that. It's all doing the best practices. And I can go to that same Blazor front end in Azure and I've got this application, same app running in Azure. Welcome. And there you go. It all works. So behind the scenes, what I actually did is I went and I technically did a right-click publish in Visual Studio. In Visual Studio, in the case of an Azure function, what will happen is it'll actually publish the front end and the back end. It publishes the entire thing. And I have access to that entire dashboard I just showed for local development. It's in the cloud for public development as well.
Oh, that's awesome.
And so with that, Safia and Matthew are going to come and do a deeper dive on how to publish, how to do all these types of things. But I want to hand it over to Paul and have Paul go a little deeper on how we can add some AI to this. And then if we have time at the end, maybe we'll even go so far as to even show some crazy scale.
If we could do some, sounds great.
We're going to do AI over Stephen Tobe's crazy blog post of like 1,000 lines. And so
I love it.
Let's do it.
Okay, sounds good. So I'll switch over to my screen. And if you all want to follow along, so actually one quick thing. Ooh, superpowers are coming out. All right, we'll show this again in the end, but if you want to get .NET 9, we have this link here, akka.ms/get-.net-9. And then also, if you want to just take a moment, grab this URL or use the QR code and you can follow along with the demos. All right, with that said, so we're going to do, I've pre-cooked a bunch of things. It makes it fun. And if I think about the last year, I would say AI has been moving so fast. It's been really fluid. We showed some stuff last year. Like we showed how we made RAG easy. I think that's evolved. We've made things way more secure by design. And we've gotten a lot further down the road of like, what are people really trying to solve? So those are some of the things I'm going to show you today. First thing, like if you hit that link, we have a sample for RAG, basically the retrieval augmented generation. I like to just say in normal terms, like you're going to chat your own data. So we have a great sample for that. We'll come here. By the way, at this point, we've moved them all to Azure samples. We've done a really good security pass on them. There's no secrets anywhere. User managed identity, all the good stuff. So if I switch over to...
And they're all AZDified as well, which means all you do is clone the repo, and then once you clone the repo, you just do AZD init, AZD up.
AZD, yep.
And so these are super easy to get in the cloud and try yourself.
Totally, yeah, I think to Scott's point, like here's an example right here. AZD init with the template, you can go that way, or just clone and say AZD up.
Yep.
Either way. And it's going to provision, like a lot of these things need AI resources, they need storage. So it's just going to take care of all that stuff for you. All right.
And I'll just give you a hint. If you try to AZD up one of these things in a particular region and you hit a problem, try another region. The AI assets are a little hard to find even still.
I agree.
And so is there...
Look at the 2s, look at the, the 3s even sometimes.
Is there a region you recommend?
I like, I would start with like East US 2, West US 3 in the US.
Okay.
Those are some good ones. Also a thing you'll notice, actually, maybe I can just, we can go off the rails, right, Scott?
Yeah.
So let's go into one of these samples.
AZD makes it very easy to try and then change your region and try again as well, so.
I just paved this machine, I forgot AZD. How could I forget to do that? That's unlike me. Well, what I was going to show is when you do an AZD up or you create a new environment, it'll list a set of data centers you can use. And we've already thought about that a bit, and we've shown you recommended regions. So if I poke all the way into the bicep here, bicep is the infrastructure as code, makes ARM easier, right? So if I go into main, you're going to see right here, and I'll make this a little bigger. You can see that we've already kind of outlined some of these data centers that are particularly good for this combination of services. So that's just a little hint. And the tooling, like AZD, picks right up on that, which is awesome. So
it used to not.
It used to not. Very true. Okay, so let's go back to the code. So let's take the RAG example first. Let's clear this. I'm a command line person, so sorry, I can't get away from that. So let's open this solution, Visual Studio. I brought my Visual Studio rig today.
So Paul's laughing awesome. when he says, we actually, a day or four before .NET Conf, most of us wipe our machines out and reinstall everything clean because we've had so many beta versions up over the years. So this is, or the months.
This machine's got stories anyway. But it's been cleansed. All right, so I'm opening this in Visual Studio, and this is the like absolute hello world of RAG, and I'm just going to show you that, and we're going to build up from here. Okay. And it is natively a function. So we're going to show this in functions today. Functions will have some advantages that we make the programming model really easy. It's kind of like you can always use the SDKs, and the SDKs are fantastic. But functions has these triggers and bindings that makes it even easier just natively to use these types.
Because you're a runtime. Technically, you're
Yeah,
a runtime.
we
and that's
are a
why
runtime.
you can add capabilities to the runtime.
So is that Shift, Alt, Enter? I like the Zen mode. I'm getting used to that. So we're going to look at here, Scott, is the step one of doing RAG, of doing retrieval augmented generation, is that you ingest a bunch of data. And that's always been one of function's superpowers. So here we're just using a normal HTTP trigger, but think of all the trigger types we have. There's blob inputs, there's queue inputs, there's event streams through Event Hub. So you've got all of those at your disposal. So we're just using actually ordinary functions here to do the ingestion. And just like Scott showed, we're going to do a little, we're posting objects in the body. We can deserialize them and kind of work with them easily. But the cool thing we're going to now is we're going to say, hey, I want the output of this function to go straight into a vector database. And I think one of the awesome things that the team's done is we now have triggers and bindings, especially bindings, that make it easy to work with common vector databases.
Stephen Tobe has a blog post he wrote about a year ago on doing RAG in .NET, and it shows, by the end of his sample, he's got like 30 or 40 lines of code to go do the vector database stuff that you're just doing in a line here.
It's literally, so this line of code right here, line 68, you can kind of follow along. We have this embedding store output. And you can, there's attributes you can set, you can kind of configure the chunking. But the key thing is just saying, hey, here's my vector database. I'm going to use the AI search service for that. Here's the model I'm going to use. So I could use GPT-4, save money, Turbo 3.5, that's fine. Pick your favorite model and just bind to it and off you go. And it doesn't even have to be just AI search. It could be.
So to be clear, all I'm going to do is take Stephen Tobe's blog post it to the function.
Yep.
And with those small lines of code, it's going to go put it in a vector database for me and wire it up to my model for me.
That's totally it. That's all you got to do. And everything else we're seeing here, this is just .NET, right? Like, hey, I want multiple return results. So I'm going to have one to give me an HTTP 200. And also at the same time, I'm going to send the search document onto embeddings.
So the idea here was we ask ourselves the questions. What's the code you're going to write every single time again and again and again and again? Writing the code to put your data in a vector database, you're going to write it again. All the embedding and chunking stuff. And so the goal of the function tech that we have here is to take that hard work away.
All right, so this, gosh, I love reading these blogs. Stephen really goes into so much detail. Even just check out the TOC. The TOC of all the things he covers with all the improvements. It's awesome. It's like a book.
And this post especially, he went deep, low level. I mean,
he went really deep.
Yeah.
And I was thinking about things that, what best practices did I want to shine the light on today? Things that help with web programming, cloud, and AI. And Jason came to mind. I think that's really a good one. But there's also these newer types that are going to help with AI. So we have like spans. Spans could have multiple kind of numerical components or floats in them. So it's a great way to represent vectors. And as we know in AI, when we're doing more fancy inference and training, and predictions, we're going to be using vectors. So that was a thing I was kind of keying into. And also, there's a great set of primitives. There's already been great primitives in .NET, like hyperbolic cosine, but you would take kind of simple values, simple scalars, and now they can actually take these spans, right, as you can see here, which will let us kind of vectorize things and work with vectors.
Right. Our hope with putting these types in .NET was to make every other .NET library that's doing ML not have to go, or AI have to go create the same types again and again. It's like, part of the goal of .NET is like, here's all the base primitives, whether we write the library or a third party writes the library.
It's like there's a library for that.
We can all share the same primitives.
That was awesome.
There was a lot of work that went behind some of this stuff where we actually went to the community and talked to them about, hey, can we all adopt the same primitives?
That's awesome. And I also love it how Mr. Tobe is showing kind of the perf benchmarks as you go, so you understand the overhead. It's really cool. So what I thought we could do is, I mentioned I would go further than last year. We'll go further than RAG. So let's take our LLM, which can search something like Tobe's blog, and we can ask questions to it. But I actually want to extend it so it understands how to do some things that Tobe would tell us to do. So it's almost like Tobe in a box. I'll
me.
do my justice, Stephen, if you're watching me, but we'll do our best here. So let's
Hopefully
come
that's the
back.
name of the sample is Toba in a box.
I think we're gonna have to go with that. I'll have to ask for permissions, of course. All right, so let's go to. So I'm gonna go to a different sample. This is the next one on the markdown. So we're gonna go to scaling. And I don't think we've even talked about scaling before.
We never have. We've told Julia. That's about it.
Yeah.
Julia's our boss.
Our way up boss. So the way I think about scaling, LLMs are really good at augmenting and generating things based on text. And it's using the corpus of data that was known when all the models ran, right? But if you get to simple things like telling the time or doing calculations, that's not really what the model was designed to do, and it was kind of a snapshot in time.
I would say a snapshot in time. It doesn't know what the current time is because it was a snapshot in time, so it doesn't really know how to go ask a clock
Totally.
what the time is.
But we as developers totally know how to do this stuff. This is kind of our wheelhouse, right? So
Daytime now, baby.
So with scaling, kind of like the name implies, you can add skills to an LLM, and it goes by a couple different names: skilling, tools, agenting is kind of the cool new name. Function calling, that's another one. Not this function, overall function. So it's just, these are all ways just to add extensions. That's something we've all done as programmers through the years. All right, so let's open this guy up, the assistant sample. And gosh, I'm really excited about this because I think function screams scaling. Here we go.
Got that circle of patience.
Yes. This is a plea to upgrade my laptop, Scott.
If you had it 4 years, you're qualified.
We're even over that. Okay, so what we're gonna do, drama aside. First thing I'm gonna do is let's take a look at the kind of external interface that we're gonna call. Okay, so I have this assistant APIs file. And that's just a few functions, and it's really simple. I have one function that's going to let you create an assistant. Think of that as an abstraction over an entire chatbot. And the chatbot's kind of special because it understands a session, and it understands kind of the state of the session. And it's got distributed state management, so I can keep coming back.
So a session in a chatbot is the history of what you've been talking to it about. So it can go back and say,
Yep.
Hey, what kind of cars are they? No, show me the red ones, show me the blue ones. And it knows you can just keep adding more to your chat.
Absolutely. And in the form of functions, to make that incredibly easy, we just have these triggers and bindings. In this case, it would be a binding where I can write the output. I can either put to a chatbot to start it, or I can post a query, or basically a question or a prompt, to the chatbot. And in using this assistant, that's all I have to do to kind of work with the chatbot. So that's step one. That's the basis. Actually, why don't we just look at that and just kind of get a feel for that?
And you're going to make this assistant use Stephen Tobe's blog post.
We're going to, I have it broke into a few pieces. So,
Okay.
so we're going to ask it some custom questions inspired by Stephen's blog post. But yeah, just knowing the content, the model already can do that. So let's hit F5. And one thing we started doing in our samples, I guess tell us if you like it, Scott did, I also did, we have these HTTP files that just makes it super easy to test a web API. So I've got that too. While this is loading.
That's a feature we added, I think, earlier this year in Visual Studio, which is...
yeah, it even can run it now in Visual Studio.
I can actually just go and open the HTTP file, click the link, and it will fire the request off, and you can look at everything, the headers, the response, the request that was sent.
Let's try it.
Super cool.
So you can see here, two HTTP-style functions were exposed. One, if you do a put, it's going to create that stateful assistant. And then we could just start asking questions of it. And instead of having to know how to curl or something that I'll clearly forget how to do, we're going to use that HTTP file. So we're going to go to View, Solution Explorer. We're going to open the HTTP file. And let's just do the very most basic thing. So let's get a new chatbot. Actually, just to uniquify it, let's get a new one. Okay, so we're going to do a put to that. And like Scott was saying, in real-time async, we're seeing the HTTP response. I think everything needed a cup of coffee.
I would close this one out just to give you more space.
Yeah. We like the debugger windows, but okay.
Make it minimize.
We all get a hiccup in the morning. Did I lose my?
You got a glitch.
All right, we'll just try it again.
It's the cloud.
We don't sweat these things. I might have to.
You might want to check your Wi-Fi and make sure your Wi-Fi is actually hooked to your phone.
Yeah.
It might have flipped back off to Corp.
Yeah, I'm doing a funny thing. I'm working inside and outside the firewalls today. So let's take Scott's suggestion.
Oh, it says connect to the phone.
Yeah, we can try this one for a sec.
So we have extreme security at Microsoft on our network. And so Paul has to jump around some of that security for some of this demo, and that's why he was using his phone or tethering to his phone for his internet connection.
I can see one other thing. Scott, tell us more about this as I fix this up real quick.
So if you watch the news at all, you've heard that Microsoft's had a huge security effort that we've been working on inside of our company. And that entails multiple levels of things that are kind of interesting. One of those is making sure that any of the code that we have, our code, our samples, our internal source code, we don't ever want to have any credential or connection strings to anything inside of one of those and you shouldn't either for your source code. And so one of our goals is to make sure that we don't have any of those left anywhere in our own code. We primarily use technologies like managed identity to solve that. Managed identity is where you actually, as an administrator, you can say this web application can talk to this SQL database. And in that case, you don't need a connection string with a password or anything like that. There's that implicit trust that was built between that. And so it means a bad actor could never steal something from us, or we can make a mistake of publishing that somewhere where somebody from outside our network could actually try to go and access the same database. We do similar things inside of our own network. There's a network where we build code. There's a network where we actually work for our daily work.
Yep.
And we now have to transverse all these all the time.
We do.
As part of our jobs, because we don't want everybody that's working in like sales, they shouldn't have access to the same network where we're running build pipelines that are compiling the applications that we use.
Totally. We're going even further. The data is super precious, so all the data now goes into its own subnet and its own network, and there's only one kind of pinhole into that.
Yep.
So we're doing all the things. Scott, you're a scholar and a friend. You let me reset that. I appreciate it. So my network seems a little happier. We just did we're back on the screen. We've created the session. And now we can start to do things. Like I mentioned, I can send lots of prompts to an LLM, but I can now do things like, what is the time in New York City? We'll do a real-time calculation. It's going to call out to a function. I'll show you in a second how that works. Hopefully everything's happy again. We just need a little drama this morning. There we go.
No.
Current time in New York City of 12:38 p.m. That's actually totally accurate. And now let's, I mentioned we're going to start moving into Mr. Tobe's blog. So let's first, if we want to work with vectors, we want to have something kind of interesting. Let's actually have the LLM create us a vector. So first I'm going to create something with 5 components, basically 5 float numbers. And here we go. So we have a vector with 5 components.
Yep.
And let's now calculate the cosh of that vector. We're going to do it across the whole thing. So we're going to send that request. And there we go. Would you like to calculate for each component? So and remember, Scott, this is stateful, so we could just say yes.
As we mentioned before, that's the session part of one of these. One of these is because you're in a session, it knows what you asked before, and you can keep refining and refining and refining.
And so here we go here. Sometimes it gets a little bit of attitude, but you just got to tell it what you want, or be very polite. There we go. And so this time it's calculating what we want. Now, this is incredibly simple. This is something we could just run on our local machine. You might be saying, well, why the cloud? But if you really think about it at scale, with all kinds of data being pushed in, all kinds of data being read, this could be streams of like millions of things per second. And if you want to do that calculation, that's not going to be the strong suit of the LLM. But now using something like a function in the cloud, we can do those calculations as things are happening in real time. We have all the compute power we need to do it. So let's close this for a second. Let's just show how we did that. So there's another file I'm going to call your attention to, the assistant skills. Let's make this full screen. So what this thing has, it just has ordinary kind of code functions. So this is the one that will actually do the get cosh. And the main thing I want to show you here is that we have a functions trigger. So very important. For most all these things I'm showing you, you need the OpenAI extension that does the triggers and bindings for OpenAI. And that's got one called this assistance and skills. And so assistance and skills can take something like a string and say, hey, when someone prompts with a string of this form, so they're basically asking you to calculate the cosh, I want you to run this function. And you can see that I used like a little token, a little X here to say that's the thing that could vary every time with a function. And kind of like what you did with model binding and kind of request binding, we're gonna automatically extrapolate what that variable is each time. Right. And we know that it's expected to be in an array. And numerically, an array is kind of a numerical representation of a vector, right? And then, we're just going to do a little bit of massaging. We're going to trim out the characters that don't make sense. We're going to split up the numbers. And we're going to create that span type that Stephen taught us in the blog. Right. And we have a span for an input, span for the output. Then we can just call these tensor primitives using that new library, and then off we go. So I think I want to do something cool that applies to AI, but I just want to show you that like the sky's the limit. So if there's mathematical libraries, business libraries that you have, that can do business functions, calculations for you. If you want to automate things like send emails or go publish to Slack, like these are all things you can do from functions, even as users like work with your chatbot or work with your generative AI.
Yeah, and Stephen Tove's RAG post from a year ago actually showed similar stuff, but in his case, it was actually code in your actual running process.
Yes.
Where it's like he had a method that you could actually add to it, and basically it's like the LLM doesn't know time, but it knows how to call that function to go figure out what time is. You tell it, hey, if somebody asks about time, yes, go do this, and you're kind of showing the same thing where you're adding some stuff.
Exactly right. Yeah, in fact, I love you brought up this example. So right now we're doing function calling, and we're registering these functions or tools with OpenAI itself. So when OpenAI sees the prompt, it knows what to do and it can find this function. But I love Stephen's example too, because it goes even further. Like think of all the interfaces that you could have in your pipeline in .NET. If one of those interfaces exists, you could call that too. So like you could actually start applying multi-models and multiple things. So Steve and I were even talking this week, we'd love to partner more. So maybe we could extend this to not only register with OpenAI, but also maybe look at what's in proc, look through DI to see what's there.
Interesting. Go look at the actual application.
Look at the application, see if there's more services we could add. So that's not there yet.
That's super
cool.
But
I want to get there.
The idea of being able to say, hey, I've got an application that has a bunch of services that OpenAI might want to care about, and it could easily find them and just call them. Then you can basically extend the LLM however you want it with whatever dynamic capabilities that you want.
Absolutely. And it's also, I think it's yet another technique to work kind of multi-model, which I think is becoming more and more common because each model has its own superpowers, its own pluses and minuses.
I mean, you really see this, I think, on the mobile phones where they want to run a local model, and then if that's not good enough, they'll go to a cloud model. I think that's going to be a common paradigm we're going to see as well. That'd be something interesting for us to go figure out how to go do a cool scenario.
Oh, I'd love to do that. Maybe that's what we could come in with the next time. So just, for everyone kind of watching this now, just please do check out in functions, we have this extension for OpenAI, and that's where you're going to see the assistant skills. That's where you're going to see embedding. That's where you're going to see completions. Just all of these things that are great to do in the SDK, they're even further simplified in functions. But wait, there's more. So I want to go even further. Let's pop over here. Let's pop out a few directories. The next thing in the bag of tricks we had for you, Scott, is orchestration. So just to put a little context around this, what we're seeing a lot is you're not going to just do one maybe prompt or one RAG scenario per request and be done. A lot of real AI scenarios are about bringing data in from multiple sources, kind of massaging it like ETL, and then running some models first that maybe even just work with the input, and then having more models that can do the generative AI. And it becomes like an orchestration or a pipeline to do these things. It becomes a real distributed app. And all the same challenges with distributed app development come in of, well, how do I make this thing reliable? What if any one step fails? And these can be long-running pipelines. So you don't want to start a long-running pipeline and fail, and then the user's on their app and they're getting a terrible experience. Also, let's just kind of keep in mind, let's be honest, like AI can be expensive, right? Like we're doing intensive computation, we're paying by the token. So we don't want to have wasteful, unreliable code. So what I'm going to show you is some techniques built into functions that are going to let you overcome this and make it really easy.
Cool.
So if you go into the orchestration sample that I posted, the theme here, we're gonna veer just slightly away from Tobe's theme for just a second, and we're just going to talk about PDFs and how do we analyze them for the sake of this. All right, so I have that sample here, and just to show you a little bit of what's going to happen, I described a sort of a pipeline. And what the pipeline's going to do is first we're going to take an input file using a function blob trigger. So this is plain old functions, taking blobs in. We can do it async. We can do it at scale.
So I drop a file into a blob. The trigger's going to fire.
Yep.
You're going to get access to the file.
Yes. We have access to the file. Now, one of the strong suits has not been cracking open files like PDFs, right? There's great, third-party utilities out there, but that's one of the things we're not super good at. But a really cool thing is we can actually bring in another capability that the AI team built, because they've seen this scenario a lot. So they have this whole document intelligence set of SDKs and services, and we can just leverage those inside a function to use document intelligence on the PDF coming in. So now it's more like a text that we know how to use.
And those are cool because those support not just PDFs, but Word docs and a variety of different formats.
Yeah, totally right. So the key kind of Azure SDK in AI that we're going to use is this form recognizer. And that has all kinds of form recognizers, and we can use the document analysis to work with PDFs. And like I said, there's more media formats these days that kind of contain the data you need, but they're not text yet.
Right.
So like this is kind of where you go to get things converted into text.
I've seen people use this actual tech to take a image of a fax and actually convert it to text.
Yeah, exactly right. You can think of like, first we thought of OCR, and now you can take all these multimedias, like you can transcribe, you can do accessibility.
It'll even describe an image in the pic. If your document has an image inside of it, it can actually tell you what the actual image in the document is as well. So it's super cool tech.
Yeah, super cool. So here we're basically going to let's look at the workflow. So we have this function that can analyze the PDF, and it's going to take advantage of that form recognizer and do the document analysis, and that's the heavy lifting. And then the last step we're going to do is we're going to call out and do a much more traditional, we're just going to do a completion using the LLM. In the completion, again, that's one of those simple kind of binding attributes that we can use. So if you kind of think about how do I chain this and do it in a reliable way, there's been patterns in Cloud Native for years and years, and some of them are called like event sourcing or journaling. The whole idea is that as you go through each sequence in a workflow, you're going to journal the state of your outputs, journal the state of the inputs, and you could rehydrate them at any time. And then you're going to use something like a queue to know if you looked at it or you didn't. So there's all this kind of stuff that you have to do to make it almost like an ACID transaction. That's hard stuff. Like we've been wrestling with that since DCOM and MTS and
well, actually even further than that, the file systems actually are journaled these days. So NTFS and Apple's file systems are all journaled too. So same kind of reasons.
Same kind of stuff. So now I'm getting to the point. Okay, so the really easy.
What are we going to do?
So what we're going to do, we're just going to use a durable function. And durable function has its own programming model where you can treat any other function as an activity. And you can just say call activity, call activity, call activity. And then when you're done, like you kind of expect that process to complete. If it completes, the whole thing is successful. But it's going to automatically journal every activity call for me. And it's going to make this thing completely resilient. So I just literally call the function 3 times. And it's going to make sure that that span of functions completely resilient. And this is like a simpler sequential workflow, but you could also do a fan out. You could do like a parallel set of tasks and say when all are complete.
Yeah, in the old programming days, that would be MSDTC. Microsoft Distributed Transaction Coordinator did the same kind of thing where you could actually make a SQL request across like 3 data centers, and it only completed if all 3 data centers actually got the
yes. Exactly right.
The update. So, and if not, it would roll the whole thing back against all those things. So,
and I think one of the kind of misnomers, a lot of people are like, hey, durable functions, is that just like a really long function? And yes, it can run a really long time. It can even wait forever, right? It can be waiting for an input. But that's not the whole point. It's this whole like state management and reliability that it adds.
Yeah, you'll hate me because my definitive example of a durable function would be, hey, Paul just bought a game from me, and my durable function is going to say wait 30 days and then send Paul an email saying, are you happy with your purchase? And that would actually work.
That would, yes. I'm going to switch networks. Remember how we talked about that?
We switching to the phone, or are we switching?
We're switching the phone because this one can get through the firewall.
Okay.
This is just the magic of Hollywood, aka Redmond. Okay, so I've got my function that's starting. It should be any second. We have a cornucopia of debugging things being attached. Although it's handy when something goes wrong that's in the debugger. So you can see it's still loading.
You have 2 minutes.
We got to make it happen. I've got a plan though. All right. And we're going to go to, we're going to take inputs as a blob. And what I've done is I've actually taken the .NET Conference PDF, which is pretty big file, 17 meg. We're going to upload that. And again, this is function, so you can do this stuff at scale. You can send millions of documents. All right. And we're going to copy this guy over. We're going to upload.
So the conference agenda for .NET Conf is being uploaded as a PDF into your function.
And in just a sec, it should start triggering, and it's going to go through that whole workflow, and it's going to start journaling it. And it's going to do it reliably. Now, you don't have to take my word for it. So I have a sneak peek at a feature that we're adding to durable functions. And this is called the Durable Task Scheduler. So if you kind of think about it, there is a stateful backend, and now we have a fully managed backend. It's much better than a storage account. It's incredibly fast. It's more secure. It's fully managed. It's fully backed up. And because it's something that we manage for you, we can actually give you way better observability because we have an interceptor that's in there kind of understanding all the calls. And so here, a big problem I can solve is I can look at the anatomy of a full orchestration or a full workflow. I can see every step. I can see kind of Gantt chart style how long it took. And if there's any failures, this is always the kind of unspoken problem with orchestration. It's hard to fix it, but we actually can give you the full state and observability for each step. So here I kind of intentionally forced it to fail. You probably didn't notice I deleted the input file, but not the output. So it's actually telling me that the output file already existed, and that's why it failed.
Okay.
So full orchestration, you can use it today. It's in Azure Functions with durable functions. There's actually a peer technology in Dapper called Dapper Workflow based on the same tech. So if you want to run multi-cloud or with Kubernetes, you can use that also.
Cool.
Yeah.
Thanks everybody for hanging out.
Yeah, thanks so much.
Please grab those samples, try them out, send Paul and I feedback, and enjoy .NET 9.
Enjoy.